Welcome you all to the Research Spark YouTube channel. So today we are going to start the unit third, feedback amplifier and oscillators. Here is the outline of this discussion. So left side you can see the syllabus for the unit third, and the right side the contents that we are going to discuss. Actually for unit third, what I have decided to make up only two sessions for this unit, because what I found that we can cover the some more portions in a single session, so it may be the convenient for you people. So just drop a comment if it is not convenient. We can also I'm thinking to again to have the four different sessions. So anyway, so here is the content. So we'll see the what is the feedback, that is introduction to the feedback and types, advantage and disadvantage of the negative feedback, then the basic feedback concepts, ideal feedback topologies, so different topologies like voltage series, shunt-series, and current amplifier, transconductance, that is series, and the shunt-shunt. So we'll see all these. So feedback. So what does it mean by the feedback exactly? So feedback simply, if you are considering the some amount of the output voltage for your input signals as well, then this will called as the feedback. So feedback process take a portion of output signal and return it to the input, and that will be the become the part of the input signals. As for example, in the right side there is a figure. You can see the register, that is RF, is feedback register. So that is why F stands for feedback only in RF. So that is, the now the because of the RF only, now the some portion of the output, that is V out, is going towards the input, and this is the inverting terminal. So now this will goes to the your amplifier. So RF is your acts as the feedback element. So the voltage gain of these ideal circuits is a function of only of the ratio of resistor and not of any individual transistor parameters. So there are the two different types of the feedback. So either it may be the negative and positive. So in the negative feedback, portion of the output signal is subtracted from the input signals. Means it will reduce the amount of the input signal. While in positive feedback, it will be added and it will increase the amount of the input voltage. So negative feedback, for example, tends to maintain a constant value of the amplifier voltage gain against variation in the transistor parameters, supply voltage, and the temperature. Positive feedback can also be used in the design of oscillator in a number of other applications. So what is the advantage of this negative feedback? So the gain sensitivity. So what will be the variations in the circuit transfer function, that is gain, as a result of changes in the transistor parameters are reduced. Also it will be independent from the temperature, so that is another advantage. Bandwidth, also the bandwidth will enhance for if we are going to have the negative feedback. Noise sensitivity, negative feedback may increase the SNR if noise is generated within the feedback loop. So just see the couple of more advantages, but there are the some more disadvantages. First is the gain reduction. So because since we are having the negative feedback, so it will reduce the gain comparatively to the open loop without feedback. Stability, again, it may be stable, it may not be stable, so now it will reduce the stability. So you have to find out whether the the feedback based amplifier is stable or not. So using the body plot or Nyquist criteria, you can find whether the system is stable or not. So now we are going to talk about the some basic feedback concept. So here in the right side figure, you can see the feedback factor beta and the amplifier, that is A, and the source is Si. So now if you will see the the gain, that is with the feedback, it will be the A divided by 1 plus of beta A. So since the denominator 1 plus beta A is in the denominator, also you can call it A into beta is equal to T, that is also called the loop gain. So if loop gain, that is the T is equal to -1, in that case the amplifier, this feedback based amplifier will oscillate and it will be not stable. So the thing is that it should always be the positive only, for that only the system will be stable. So now we are going to talk about the different topologies. So we have the four different topologies, either series shunt, shunt series or shunt shunt. So let's talk first series shunt configuration. So series shunt configurations means like left side series, right side shunt. So here you can see the feedback that is in series with the input voltage, that is Vi. However, shunt in the right side means the output voltage we are considering in the parallel and taking the output voltage, and shunt that is with the inputs. Now this is the circuit, and correspondingly the ideal series circuit topologies you can develop in the extreme right, and then find out the gain. Then the major thing is to find out the input resistance and output resistance with the help of feedback, means without feedback and with the help and with the feedback. So initially like if we will solve with the help of this feedback, then you can find the feedback amount, that is voltage, and Ri, that is input resistance. With feedback it will be calculated as Ri into 1 plus beta A. So now the input resistance with feedback is increased by the amount of 1 plus beta A. Similarly, in the right side, like you can check, the output resistance with feedback is now Ro divided by 1 plus beta A. So this is telling the output resistance will decreased by the amount 1 plus beta A. So how to calculate the process exactly, you can check it, like we are finding the VE and RI in order to calculate the input resistance, and similarly we are finding the output voltage and output current in order to find out the output resistance, and then dividing to find out the resistance. Another one is the shunt series configuration. So now see the first picture image that contains the shunt series, means first in the left side shunt means parallel, right side series means the in the series one. So here now again you can see the we are adding the amount of the current that we are feedback, that we have the feedback directly and towards the input terminal, so that is shunt. Now we are collecting the current from the right side. Now again you can find out the input resistance and output resistance. Since this is shunt series, so input resistance will be decreased by the same amount 1 plus beta A, and output resistance will increased by the same amount 1 plus beta A. Calculations, just check it. This is very simple. To find out the input resistance, use the same similar equations Vi and Ii, you will get the values. Similarly, series configurations means both are in series, left side, right side, both are in series. And again, since both are in series, so input resistance and output resistance both will be increased by the same amount 1 plus beta A. And shunt here, just check the gain, how the gain will affected. So gain will be reduced since this is shunt. So now gain with feedback it will be A divided by 1 plus of beta A. So major thing is to know the gain, input resistance and output resistance with and without feedback for these different topologies. So these are the configurations are possible in the feedback. So here is the summary of these topologies you can see here. So we have the all these configurations: series shunt series, shunt. So for series shunt, if you remember, the gain is reduced by 1 plus beta A, resistance is increased, input resistance and output resistance will decreased. Similarly, you can check all other topologies and find out the how the your feedback is affecting the gain and the input and output resistance. So thank you for listening, and in the next session we will talk about the stability analysis of the feedback circuit, BCT, MOSFET, operational amplifier, and then we will talk about the oscillators. So principle of oscillations, classification of oscillator, and we'll see also the some examples, that is RC, LC, crystal oscillators. Thank you. If you have any doubts, please drop your comments. Thank